Okay, the second part of this section is talking about the integrals of the exponential function. All right, and we're going to use a u substitution in order to take the integral. If you notice, the integral of e to the x is going to be e to the x because we found out in the last half of this section that the derivative of e to the x is e to the x. All right. Well, same thing. You know, if we have something other than an x out here, we got to do something. We got to make it a u. So we're going to use our u substitution in order to evaluate an integral for the exponential function. So let's go ahead here in example 4. I'm down here now. Let's do the integral of 3x, e to the 3x plus 1. Well, let's make u equal 3x plus 1. And it's the same thing as our u substitution. Let's take the derivative. So du equals 3 dx, right? And solve for dx. So we'll get du over 3 equals dx. All right. Well, okay, so now we have the integral of e to the u, and we need du in there, so we need to substitute in for dx. So we're going to have du over 3. And what we learned, we know that we can take out any constant, so we're multiplying by 1/3 right down here, so we can pull that 1/3 out. So we have 1/3 times the integral of e to the u du. All right, well, up here it says the integral of e to the u du is just e to the u, so what we have left over then is just 1/3 e to the u. Well, we can go ahead and plug our u back in, which is 3x plus 1, and then obviously plus c because we're taking an indefinite integral. All right, there's example 4. Moving on. Let's get a few there. There's example 5 here. Okay, evaluate this integral. Well, let's just try. Let's see what happens when we make this negative x squared u. So let's see that u equal negative x squared. Well, okay, then du is going to equal negative 2x dx. And we need to solve for dx. So du equals a negative 2x du over 2x, sorry. All right, so we're going to go ahead and we're going to substitute that in. So I have the integral of 5x e to the u, and then let's substitute in for our dx. So I have du all over negative 2x. Well, these x's can cancel out. And we know that we can take out any constants that we're multiplying. So we can pull a negative 5 halves out. And all I've left over then is the integral of e to the u du. That's good because we know what that is. So it's going to be negative 5 halves e to the u. And we'll go ahead and we'll plug our u back in. So negative x squared there. Okay? Plus c. So there's that example there. Moving on. Evaluate, I believe that's supposed to say the integral. Yeah, evaluate the integral of e to the 1 all over x divided by x squared. All right, so again, let's make the exponent equal u. So let's let u equal 1 all over x. So then du is going to equal, remember, if we move this up to the top, it's negative 1. We bring the power down and we subtract 1. That's how we take derivatives. So we're going to get a negative x to the negative 2 power. So we get negative 1 all over x squared for our derivative. So du equals negative 1 all over x squared dx. And again, let's solve for dx. All right, let's multiply by an x squared. So I have x squared du, actually negative x squared du equals dx. So that's what dx equals, negative x squared du. So let's go ahead and let's plug that in. So I have the integral of e to the e to the u, I guess we made that substitution, times, or divided by x squared times a negative x squared du. Well, this is like saying it's over 1. So let's go ahead and let's cancel these x squareds out, which is great. I didn't mean to draw a line through my negative sign. We still have my negative sign. So let's pull our negative 1 out. So I have negative the integral of e to the u du. And that's good because we know what that is. So we're going to have a negative. That integral is going to equal negative e to the u, which is 1 all over x, right? Plus c. And that's it right there. And example 7 here. I believe this is the last example. All right. Again, let's make the exponent equal u. So let's let u equal the cosine of x. Then du, the derivative of cosine, is going to be negative sine of x, right? Dx. Well, we want to get dx by itself, so we're going to divide by negative sine. So du all over negative sine of x equals dx. All right, let's go ahead and substitute in. So I have the integral of sine x e to the u, and then dx equals du all over negative sine x. Well, that's good. It's a good thing here is we can cancel our signs out, right? And I'm still dividing by -1, but we know we can pull that -1 out. So I have negative the integral of e to the u du. So I get my integral then is negative e, and let's plug u back in, cosine of x plus c. All right? And remember, we can always check ourselves. When we get our integral, we can always take the derivative of it and make sure we ended up with our original problem. So, hope this helps. We'll see you in class.